So what we're going to be talking about today is how we manipulate radicals using different operations. Okay, so again, a lot of this is going to be reviewed from the past few days. We'll get about halfway through this lesson. You ready? Say yes? No, we cannot just watch a movie. No, we don't ever watch movies in math class. I'm sorry. No, I don't get free days. No. Next page. Okay. If the nth root of A and the nth root of B are real numbers, then the nth root of A times the nth root of B is, who knows? You didn't? There was no question on the first page. Andrew, we got to. What's the nth root of A times the nth root of B? Good, the nth root of A times B. So what do you notice that they have in common? Which is called the what? The index. They have the same index, right? When we're multiplying and dividing radicals, you have to make sure that you have the same index. Okay, the index has to be the same in order to multiply or divide. And then when you do multiply, all you do is multiply the, what's the word? Radicands. Very good. Okay. Okay, so let's try this one. Square root of 2 times the square root of 8. What's the index? 2. Very good. Okay, what is it? Uh-huh. Very good. And what's the square root of 16 equal? Thank you. Plus and minus 4. It's in the book, tab 3. Plus and minus 4. Okay? Remember, even index, you're always going to have that plus and minus. Odd, you do not. Book, it's in your book. And then hit 3. No, not control book, just book. Okay. Yes, it's just smaller. Okay. Ready? Next page. All right, square root of 3, square root of 12. So why don't you guys go ahead and try these 3, and then we'll go over them. So go ahead and give them a shot. We're going to pause here. Okay, so the first one, 3 times 12 gives us 36. Square root of 36 is plus and minus 6, right? It's plus and minus because the index is even. It's always plus and minus when it's even. Is it plus and minus when it's odd? No. Okay, so cube root of 3 times cube root of 9. Cube root of negative 27. Index is odd, so it's not plus and minus. So what number do I multiply by itself 3 times to get negative 27? Negative 3. Okay, negative 3 times negative 3 is a positive 9. Positive 9 times a negative 3 is a negative 27. We get it? Okay, 4th root of 4 times the 4th root of negative 4. Okay, is there any negative number that you can multiply by itself 4 times to get another negative number? No. Why? What's a negative times a negative? Times a negative? Negative times a negative? Positive. So any negative value raised to the 4th power becomes what? Positive. Any negative value raised to an even power becomes what? Positive. Okay? So you can't take an even index and try and find the root for a negative value. Okay? This does not exist. And in a couple of days, we're going to learn how to work with those negative square roots, 4th roots, 6th roots. Okay? But we'll leave that for a couple days from now. Are we good? Okay. All right. So simplifying, we did a ton of practice with this yesterday, right? So I want you guys to go ahead and try A, B, C, and D, and I'll give you like 5 minutes, and then we'll go over them together. Good? All right, go ahead. Okay, square root of 72x cubed. How are we going to break it down? No. No, ma'am. 36 and 2. If you use 9 and 8, you'll have to reduce the second time, which is more work than you want to do. Okay? Okay, x cubed, how are you going to break that down? Good. Are we okay with that? Square root of 36? Plus and minus 6. Square root of x squared? X. And then those go back under the radical, so we have plus and minus 6x square root of 2x. Okay? Are we okay? Okay. For the rest of these, we're going to work with just the principal square root. Principal meaning P starts the word principal. P. Come on, remember. Principal root. Is it going to go with the negative?
Positive.
Positive. Principal P positive. The principal, Mr. Bub, is positive. He's a happy-go-lucky guy. Get it? Principal P positive. Got it? You making the connection? You're all looking at me like I'm crazy. All right. Huh? I didn't use that one last year. Okay. Cube root of 80n to the 5th. Cube root. So we got to think about perfect cubes. What are my perfect cubes? 1, 8, 27, 64, 125. Okay, good enough. All right, so how are we going to break apart that 80? Good, 8 and 10. N to the 5th. Remember, index has to divide into power. How are we going to break it up? Good, n cubed, n squared. Very good. Okay. Cube root of 8, 2. Cube root of 10, leave it. Cube root of n cubed, n. Cube root of n squared, leave it. So 2n cube root of 10n squared. How do we do with that one? Good? All right, let's try C. 50x to the 4th. How are we going to break it apart? 25 and 2, good. And do I need to break apart x to the 4th? Why? What goes into it? Be more specific. The index divides into that power. Good. What's my index again? 2. Good. Okay. Leave that x to the 4th. Square root of 25? Okay. Square root of 2? No. Square root of x to the 4th. Good. So 5x squared, square root of 2. We doing okay, guys? We're going to deal with the principal root for these from now on, unless they specify otherwise. We're okay. Yes, you could put plus and minus, absolutely. Okay, one more. Square root of 18x to the 4th. How are we going to break it apart? 9 and 2, great. Do I need to do anything to that x to the 4th? No. So I get 3x squared square root of 2. Good? We're pretty comfortable with reducing these radicals now? Have I beaten it into your brains? Okay. Okay, let's talk about multiplying. Do we need like radicals to multiply? No, we don't. What do we need? Like indexes, okay? Have to have the same index in order to multiply. So what I'm going to ask you to do here, and you've already done this, so this isn't new, I want you to multiply and reduce, or reduce and then multiply, whatever you choose to do, okay? So go ahead and simplify these two out. We're going to pause this here for a few minutes. Okay, let's go over A. How many of you reduced first and then multiplied? A couple of you, okay. So let's try that method first, and then the other one will multiply first and then reduce. Sound good? Either way it works. All right, so how am I going to reduce 54? 27 and 2. Remember, we're dealing with cube roots. We want perfect cubes. Can I reduce x squared? And how about y cubed? We're just going to leave that, right? Okay. Cube root of 5x cubed. What am I going to do with that y? Y cubed and y, right? We want to be able to break them apart so that we can take perfect cube. All right, cube root of 27. 3. Cube root of y cubed. Y. So I'm left with 3y cube root of 2x squared. Are we okay with that? Okay. Next piece. Cube root of 5. Leave it. Cube root of x cubed. Cube root of y cubed. So I'm left with cube root of 5y. Are we okay? All right, so now I can multiply. 3xy squared, y times y, cube root of 10x squared y. Can that be reduced any further? No, that's it. Okay, cube root, the index is larger than any of the exponents. Can't reduce it any further. Okay, 10 you can't break down into two numbers where one is a perfect cube, so that's good to go. You ready to try the next one? Thank you. One answer. Okay. Let's give some space here. All right, so this one we're going to multiply first, then we do reduce, okay? So we multiply the numbers out front. What do we get? Coefficients. 6. 7 times 21. I'm sorry? 147. Okay? X to the 6th and y squared. Okay? All right. So we've got 147. We need to break that apart. How? 49 and 3. Very good. Do I need to break down x to the 6th? What's my index? Does it divide into 6? So do I need to break down? No. Leave it x to the 6th. How about y squared? Do I need to break that down? No. Okay. So, square root of 49, 7. 7 times 6, 42. Square root of 3, leave it. Square root of x to the 6. X cubed. Square root of y squared. Y. So I've got 42 x cubed y square roots of 3. What happens to the 6? What's my index? What's 6 divided by 2? Okay, square root of x to the 6 is x cubed. It comes out. What happened to... Oh, what's square root of 49? 7. What's 7 times 6? 42. You multiply it. Okay? All right, how are we doing, guys? We're okay? All right, let's go to the next page. Can I make this go away? Joe? Yeah? Okay. All right, so let's talk division. Nth root of A divided by the nth root of B. Again, you have to have the same index in order to do this. So the nth root of A divided by the nth root of B is going to be the nth root of A divided by B. Okay, you just divide the radicands. You keep the index, divide the radicands. I'll help you. Okay, we're going to do control, caret. We're going to put the n, and come in here and put your fractions. There you go. You're welcome. Okay, so you're going to divide, and then you're going to reduce if you can. Okay, divide and reduce. So why don't you guys go ahead and try A and B, and then we'll go over them together. Okay. All right, cube root of 32 divided by the cube root of 4. Cube root of negative 8. Very good. What's the cube root of negative 8? Negative 2. Excellent. You guys did okay with that one? All righty. Cube root of 162x to the 5th divided by cube root of 3x squared. Good. 54x cubed. We subtract those exponents, right? Okay. So how do I break down 54? Very good. 27 and 2. You guys are getting the hang of this. and leave that x cubed. Good. 3x cube root of 2. Because cube root of 27 is 3. Cube root of x cubed is x. All right, so we're going to have to pick up here next class. We'll finish this lesson next class. Homework is pages 6 and 7. Now, when you're adding and subtracting radicals, what do you have to have? Like radicals, like radicands, and the same index, right? So when you're adding and subtracting, you have to have same index, same radicand. Okay, so that's just a little reminder. Again, you guys know that you did it in 9th grade. So make sure you have the same index, same radicand before you add together the numbers that are out front. Okay, 6 and 7, honey. Yeah.